and welcome to Math Made Easy by Planet Spark. My name is Nidhi and I am here again with you with a new chapter everybody. Last time हमने grade 9 का circles chapter complete किया था with all the theorems and questions there. Now we have circles chapter from grade 10. Right? तो जो भी additional theorems and concepts हैं हमारे पास in grade 10 that we will be covering here today. Right everybody? Let's get started. Now we have tangents introduced here in grade 10. Right? What are tangents everybody? Do you know that? Yes? First of all, let's quickly go through circles what we already know. A circle we know is defined by all the points at a fixed distance from the center, and tangent is what? A line that touches the circle at exactly one point. Circle की definition we all know, right everybody? That we get fixed points at a fixed distance there, right? Now let's say we have a circle here and from a point outside the circle, right? यहाँ से हम draw करेंगे tangents to the circle. That means वो straight lines which just touches the circles at one point, right? Here this is the point of contact, here this is the point of contact. So what do we have here? We have the tangents to the circle. Let's say this point is P, here this point is A and this point is B. So I can say PA and PB are what? Are the tangents to the circle, right? Okay then. Now a tangent is always perpendicular to the radius at the point of contact. अब ये theorem हमारे पास grade 9 में भी है which we have proved the last time, right? Same concept we will be using here. Let's say this is the circle O here and we are joining the radius, center O. So OA and OB both are the radii of the same circle, so they will be equal. Now we can join PO as well. Remember in the last video we did it that we have proved these two triangles to be congruent, right? And from there we can prove कि ये angles equal होंगे and these two lines PA and PB will be equal. That means the lengths will be equal there. Okay, so we can say from an external point the lengths of the tangent drawn to the circle will be equal, right? And यहाँ पे ये angle क्या होगा? 90 degree, because this is the shortest distance between a point and a line, which is the perpendicular distance. That also we proved there, right? If you have missed it, quickly go and check the link below everybody. Okay, so we know all of this here. 90 degree angles होंगे हमारे पास. RHS congruency से we can prove the triangles to be congruent and the tangents will have the equal length. So we can say two equal tangents can be drawn from any external point there. Okay then everybody, let's move ahead then. Now a line may be outside the circle, right, when there is no intersection, or we can have a secant there, that is two intersection points are there, or a tangent can be there, that is one intersection point. So three possibilities are there with us. Okay, let's see all three of them. Again, let's take a circle here. Okay, so first one is no intersection. Let's say a straight line is here जो हमारे circle से कुछ distance पे है, right? It's not touching the circle, it's not intersecting the circle. Distance is there, so no intersection is there, right? Let's see another possibility. When the line passes through the circle, such line is known as secant to a circle, right everybody? And here we will have 2 points of contact, right? Circle के through pass हो जाएगी ये line, and this portion that is inside the circle that becomes the chord for the circle, right? Because it is joining 2 points on the boundary of the circle, just this portion, right? पूरी line की अगर हम बात करें, that is secant to the circle. And the third case, as we just discussed, when it just touches the circle, one point of intersection, right? 1, 2 and here 0. Then it becomes a tangent to a circle. Right everybody? Okay then. Then practical applications are there for tangents with us. That is, tangent properties are used in real life systems. Like what? Wheels, pulleys and gears, where motion or force acts along the tangent, right? अभी हमें क्या पता है that radius is perpendicular to the tangent. How are we going to use it? In motion, let's say we have a wheel here, okay, and it's rotating like this. So in this direction the wheel is moving, right? So what can we say here? Here the radius will be perpendicular to the direction of motion at any point there, right? If that is how the motion is happening at any point on the wheel, if we check, the radius will be perpendicular to the direction of the motion. That means the direction of the motion is actually the tangent there. Right, everybody? Okay then. Now if you all have got it, let's solve some questions there. First one. In the figure, O is the center of the circle. PQ is a chord. Here we have a chord, right? OR is perpendicular to PQ. This is OR which is perpendicular to PQ. Which of the following statement is true? Let's just see. R must be the midpoint of the chord PQ. This R. Is it the midpoint? It's not even on the chord, right? Then OR is the radius of the circle, okay? O and R. O is the center, R is the point on the circle, on the circumference of the circle. So will that be a radius? Yes, that will be a radius. PQ is tangent to the circle. PQ is passing through the circle. So that will be what? That will be a secant there, right? Not a tangent. R must lie outside this circle. Okay, is there any condition given as such? No. So the only true statement we have here is B, that OR is the radius of the circle because R is there on the boundary of the circle given in the figure, right? Okay then, next one. Two tangents PA and PB are drawn from an external point P to the circle with center. Oh, okay. Here we have the external point P. From here, PA and PB, these two tangents are drawn there. What do we know about it? The lengths will be equal, right? So we already know PA and PB are equal. And it's given also कि लेंथ क्या है हमारे पास दोनों की 12 सेंटीमीटर. ओके जी. The distance from P to the center of the circle is also given. P is joined to the center of the circle, that is O, and that distance is given to be 13 centimeter, right? What do we have to find? The radius of the circle. Okay, very easy question, right? Because we know here OAP, this triangle is forming, and what do we know about this triangle? That this is a right angle triangle. How, everybody? Quickly tell me in the comments. Yes. Absolutely correct. Radius is perpendicular to the tangent at the point of contact there. So in right angle triangle OAP, two of the sides are already given. We have to find the third one. Which property can we use here? Yes, tell me in the comments. Yes, Pythagoras theorem. Correct, everybody. That gives us the relation between the hypotenuse, the base and the perpendicular. That is, hypotenuse square is equal to base square plus perpendicular square. Right? You can mention it here by Pythagoras theorem. Right. So hypotenuse is what? The side opposite to the 90-degree angle. That is 13. So 13 square is equal to 12 square plus p square. Right? That is 169 is equal to 144 plus p square. P square is equal to what? 25. P will be what? 5 centimeters. So that is the radius. Positive one we are taking here because we are talking about lengths. Lengths can't be negative. Right? तो क्या आ गई हमारे पास radius? Radius is 5 centimeters. And that is the right answer. Next question, everyone. 2 points A and B lie outside the circle with center O. Point A is further from the center than point B. Okay then. Let's have the figure, then we'll move ahead. जितना given है, first of all let's have it here in the figure. दो points हैं हमारे पास outside the circle A and B. Okay. And A is further from the center. Okay. तो A जो है वो center से दूर है rather than B. Right? So B will be the near one, A will be the farther one. Let's say this is the center O here. Then, can both points have two tangents drawn to the circle? Absolutely. Why not? No matter how many points we have there outside the circle, from any point outside the circle, we can draw two tangents there. Right? Let's see here. So from B, let's say these two tangents are there. And from the point A, let's say these two tangents are there. Okay, you can just draw them in a way that they just touch the circle. Right? Absolutely. Then the question is, okay, so the answer here is yes. Are the tangents from point A longer than those from point B? Justify. Yes, everybody. Isn't it obvious? एक point जो center से दूर है. From there, if we take these two distances here, obviously they will be longer than this distance here, right? So we can say yes, the tangents from the point that is at a further distance there, that will be more there, right? If we join these 2 points also to the center, then also we can say yes, OB is closer to center. That means OB distance is less than OA, right? OB is less than OA. Radius will be the same. Again, triangles will be forming. You can use Pythagoras theorem in the relationship, and there also you can prove that these distances, right, of the tangents, the lengths of the tangents for A will be longer than those for B. So we can say yes, that is also true. Okay then. Next one. From an external point P, two tangents PA and PB are drawn to the circle centered at O. Okay, circle is there, this is the center O, the point outside the circle, that is P. From P, two tangents are drawn there, point A or point P PA and PB are the two tangents there. What do we know here? That PA and PB will be equal. From any external points, the tangents are having the same length there. Okay then, given that OA is perpendicular to PA, yes, here this radius OA will be perpendicular to the tangent, obviously. OB and PB are perpendicular, yes, again radius is perpendicular to the tangent. And OA is equal to OB because both are the radius of the same circle. Prove that PA is equal to PB. Okay, now we have to prove it. We know how the proof proceeds. Yes everybody, क्या करना है हमें? बस इन दो triangles को congruent prove करना है and our work will be done. Now the question is, what should be the criteria? Yes, by the time I am writing the names of the triangles, everybody, quickly tell me in the comments, कौन सा criteria हम use करेंगे? Already we discussed in the video. Okay, tell me, in triangle AOP and triangle BOP. Yes, everybody. Radius of the same circle, OA is equal to OB. Both are the radius. Then दोनों triangles में I can see a common side there, OP. Yes, common. And this is actually the hypotenuse for both the right angle triangles, isn't it everybody? Right angle triangle, opposite side. Here also right angle, opposite side, right? So we can say that is the hypotenuse. And 90-degree angle तो है ही हमारे पास. So we can say 90-degree angle, 90-degree angle, again common. So 90-degree angle अगर हमने use किया है, so what is the criteria there? We have the right angle, we have the hypotenuse, we have one side. So yes, RHS congruency criteria. By RHS rule, the triangles are congruent, right? Then by CPCT, we can say PA is equal to PB. Hence, proved. Right? Okay then, next one everybody. A wheel of radius 7 cm is rolling on a flat surface without slipping, right? Proper motion hai, no slipping is there. What is the direction of the motion of a point on the rim of the wheel when it is at the top of the wheel? Remember what we discussed about motion everybody? बस वो एक fact याद कर लो and you will be sorted. Okay, so let's take a circle here. Okay, let's say we have a wheel here. Wheel में we are given with the motion that it is rolling on a flat surface. Let's say it is rolling like this. Okay, so this is how it's moving and in that direction movement will be happening, right? So we have to discuss the direction of motion on the rim of the wheel when it is at the top of the wheel. So at this point, what will be the direction of the motion? Yes, everybody. Let's say this is the center of the wheel and this is the radius I am joining there, radius of the wheel. So what do we know there? Motion ki direction will be perpendicular to the radius there. So radius is vertical, right? So direction of motion will be perpendicular to it like this, and in which direction? Forward. It will move forward as the force is applied in that direction, right? So this is the direction of the motion in the horizontal direction. So कहाँ move करेगा हमारा wheel? We can say horizontally forward. That is option C is the right answer. एक ही चीज हमें याद करनी है in case of motions, right? That is the direction of the motion is what? It is perpendicular to the radius at any point there on the wheel or pulley or whatever is there. Right? When two or more are being connected, then tangents हम y use करेंगे. कैसे? Let's see the next question for that. Okay then. A pulley system consists of two wheels with radii 6 cm and 9 cm. Okay, then if the centers of the wheels are 25 cm apart, calculate the length of the belt connecting the two pulleys along the external tangents. Okay, first of all, let's have the figure here. अब किसका केस है ये तो पढ़ के समझ आ गया होगा. Yes everybody, direct common tangents, right? So let's have the figure here. Then formula also I'll tell you. Okay then, so we need two circles there. Let's say this is a circle and this is another circle. Okay then. So radius are given 6 cm and 9 cm. Let's say 6 cm. This is 9 cm, right? Then over them a belt is there. So from here to here. Right? So these are what? These are common tangents there. And how do we find the length of the common tangents there when we have two circles? Yes everybody, that is the formula. 2 times under root d square minus bracket r1 minus r2 whole square. R1 and R2 kya hai? The radii of these two circles. And d is what? The distance between the centers. So let's say I am putting the distance here in this way. From here to here. Let's say this point is A, this point is B. And distance between the centers of the wheel is also given to us. 25 centimeters. Everything is given everybody. Radius hai hamare paas. Distance is there, so we can find the length there. So let's do that. Okay then. Plug everything into this formula. 2 times under the root. 25 square minus any of the radii you can take whole square hai to negative sign bhi aayega, so it's not a problem, right? So we have, let's say, 9 minus 6 whole square. That is 2 times under root 625 minus 3 whole square, that is 9. 2 times under root 616. Right everybody? You can find this value in decimals, you can put the answer. And the answer you're going to get will be 49.6 centimeters. That is the length of the belt there. So these two circles are what? Nothing but two pulleys, they are connected by this belt. So we just had to find the length of the common tangent there. Okay. Next one everybody. Okay, that was all. Let's quickly summarize what we learned here. Okay then. A circle, we know, has key elements like radius, diameter, chord, lines that intersect. Right. When we have a line and a circle there, 3 possibilities are there. Ki intersect nahi karegi, so no point of intersection, or we can say 0 points of intersection. When it passes through the circle, then it becomes a secant and there are 2 points of intersection. When it just touches the circle, it becomes a tangent and there is 1 point of intersection. Right. A tangent touches the circle at exactly 1 point and is always perpendicular to the radius at that point. Okay. From an external point, exactly 2 equal length tangents can be drawn to a circle. And while from a point inside the circle, no tangent is possible. Obviously, circle hai hamare paas. From inside the circle, if a point is there, can we draw a tangent there? Yes? Not possible. If the point is on the circle, then through that only one tangent can pass there. Okay, so 0 inside, 1 if it's on the circle. If it is outside the circle, then from there we can draw 2 tangents there. Remember this everybody. Next one, tangent properties apply in real life systems like wheels, pulleys, gears, and where motion or force acts along the tangent direction. Right. Okay then everybody, that was all for today. Next video, we'll be discussing more theorems related to circles there. So stay tuned. Thank you. Bye-bye.